Welcome everyone to another CTC Software webinar. My name is Sean Zerbis, the Director of BIM Development here at CTC Software, and today we get to start a brand new fun series. It's focusing on the MEP Productivity Pack, and we're going to talk about some custom content creation. And in today's session, we're focusing on building the Trane computer room air conditioning unit. And this is part one of what's likely to be a two-part series on this unit. We've got other ones coming in the near future too. So we hope you take a look at our events page and see if there's other MEP Productivity Pack sessions for custom content building that might interest you. As always, of course, we try to keep our eyes on the Q&A window. So if you've got questions about today's topic, I expect there probably will be some. And if you want them answered in line, throw them in directly. And then also, in case it doesn't fit well to answer the question in line, we will answer the question at the end in the large QA session that we allow when we're doing live webinars. And also, as always, of course, this is recorded. So if you're watching this up on the YouTubes, fantastic. You can throw questions there. And also, we encourage you to subscribe to the channel there so you can be notified when other parts of this series go live. So with that, let's talk in depth about today's topic, and then we'll get into it here. So in the world of MEP and building modeling, one of the biggest successes that you need to know is how to generate your own custom content. It is absolutely impossible for us as the provider of this pack to give every single piece of content to the industry. It's not possible, and they change so much that you got to know how to make some updates to it anyway. It's just wise. Now, if you don't know how to efficiently author Revit family content in the first place, and if the manufacturer doesn't provide quality Revit families, which is sadly all too common, especially the ones that align with the MEP, it can be really daunting to know how to do this. We need to know how to work with these shared parameters and work within the workflows of this. So in this webinar, my goal is to walk you through creating, as best we can, the Trane computer room air conditioning kind of product. Now, not the entire line. Don't get your hopes up too far up there. We're going to create a part of the product line. And in this session, we're going to talk about what it is we're going to be creating, and we're going to establish models based of connector positions and some preliminary properties for this particular unit. And it certainly could be expanded to the rest of the units if we really wanted to. Depends on how aggressive we get with the deletion of some of the settings inside of here. So we'll talk about that as we go through. Now we're going to go through a few important things in this session. We're going to talk about the master equipment family template, or templates, because there's more than one of them. We're going to start this series talking about kind of the general theory of master equipment templates throughout all of the different areas in the Revit MEP Productivity Pack. We're also then going to outline specifically the Trane computer room air conditioning unit. We are going to step into one of those master equipment families that we select, and we're going to begin removing all of the unnecessary or unneeded connector features from the family. That's going to help us navigate a lot more easily. We're going to take a look at two different ways you can do this. One is just the standard way. One is going to be a more automated way. And then ultimately, near the end, assuming GoToWebinar is friendly today and doesn't cause me to run too slowly, as sometimes it does when I'm sharing screens, we're going to try to get through establishing all of the relevant connector locations and some of their base properties for one model number. And then we're going to talk about some other things in future sessions. In fact, let's take a real quick look at the overall outline of the whole process here. We just outlined 4 of the items for today, and we're going to try to get through those in this part 1 session. We're also going to take a look in the next sessions here about refining connector values from cut sheets. We're going to talk about, so we're going to take those cut sheets that we have, and we're going to do some more value definitions, specifically kind of establishing as many of the types and values as we can. And then, of course, as always, when you're dealing with family content, we're going to try and load it and use it, test it a little bit, and see if it gives us the outputs that we expect. Once again, in part 1, we are talking about these first 4 bullet points in this particular session. So let's take a look first at the equipment configurator. We're going to introduce it in its relation to the MEP Productivity Pack. So if you're not using the MEP Productivity Pack, or if you don't know a fair amount about MEP family creation, I encourage you to continue watching this so you have some ideas of what to look for, but you need to know regular Revit family creation as well. You need to be fairly proficient there, especially understanding MEP connectors and some of the stuff that should be hooked up for them. But we're going to go through what exists within the MEP Productivity Pack and the content that comes along with it, so you know how to customize and modify it specifically. So within the equipment configurator, there are different kinds of configurators that you can begin with. And we're going to talk about those different kinds of configurators. Now, we're going to focus on one in particular today, and we're going to take a deep dive as to what exactly is in that particular configurator. We're going to investigate some of the parameters, and we're going to take a look at some of the easiest manipulation techniques that we can go through to work with this configurator. I'm going to talk through a couple of strategies you can use, make some recommendations, and you can certainly take this and use it however is most appropriate for you. I'll try to give you as many tips as I can throughout this session so you can select the right equipment configurator for your needs when you're doing your piece of equipment that isn't what we're doing today. Or even if you are following along and you're doing what you have today, that's great. You can do that too. If you have the cut sheets, which you probably don't, but that's fine. So let's take a look in Revit Live about where we can investigate some of this content. Now, one of the first places we can go over here is the family, or the project browser, of course, and we can expand out the families collection and take a look through all the categories. Now, each of these categories, many of these categories, will have some kind of configurator in it. The one that we're focusing on today specifically is some mechanical equipment. And if you look at the very top of the mechanical equipment list, you'll actually see 3 different potential configurators that you can use to start a family. There's other ways of starting content as well. If I was to say want a plumbing configurator, let's say I go down to the P's down here, plumbing fixtures. In the plumbing fixtures, there's a plumbing fixture configurator. If you needed some kind of a custom air terminal, which actually is one of the sessions we have planned in the future, we'll be up here in the air terminals area, and we'll be looking at these little underscore prefixed ones, which are the default ceiling, exhaust, return, and supply diffusers or grills. And then you can use these to start something new. Now, below that, you'll see all of the custom ones that are pre-built. Another technique, instead of using just the baseline default, you can also start with an existing piece of equipment that's close to what you want. That's actually what I typically recommend. You know, if I was going to go in here and build a brand new piece of equipment, I would look for something that's similar. And the best way that I've found to go find that is to jump into the mechanical test elements view here. In the MEP Productivity Pack, I'm in the sample model, or cloud model in this case. In the test elements subsection here in this sample model for electrical, fire protection, mechanical, plumbing, all these areas here, there are a ton of views that are pre-set up, in this case in the 3D views, that are all ready to go to show you every single instance of every type that's in this model, spread out and labeled as clearly as possible here. So all the air terminals, mechanical duct and pipe components, like all this stuff is here. And you can use this as your starting point. Find something that looks moderately similar, that is sort of in the product category of what you're looking for, and you can use that as your starting point. So over here, for example, if I wanted to start with something a bit more simplistic here, let's uncheck exclude options so I can get access to this. There's a generic or kind of general setting air handling unit here, which has a lot of the settings. Now, this is effectively the mechanical equipment configurator itself. It's just got some specific properties for some specific products. In this case, a generic chilled water and electric reheat air handling unit, right? And there's other types that are available inside of here as well. Oh, great. Now, this isn't wanting to respond fast for me, which is fun. All right, there's a Daikin Skyline component in here, right? That was custom built. So that you can use these types of families that pre-exist or that are similar enough to what you're building as your starting point, and then just do a save as of that family and make your own. Build up whatever it is you want, and you have fewer items to contend with. Now, since today, what we're going to try to do is build this as from scratch as possible using the most complex possible piece of equipment, what I'm going to be doing is leveraging this specific HVAC configurator here. So I'm going to edit this out of the project intentionally, this HVAC configurator. I'm going to edit it out. This has everything in it. In fact, a lot of the documentation in the user guide focuses on this family specifically for its configuration. And if we zoom into this, what you'll notice is that pretty much every single possible connector pair or connector set is out here. They're all hooked up to potential parameters. So if I select this guy here, for example, this is a hydronic return for refrigerant gas. So this is the gas line going back to like a DX type system, and it has its information hooked up as best it possibly can be. Same thing over here. If this is chilled water coil return, right? And it's got things like its flow hooked up and its pressure drop. And so this data is already pre-specified. So all I have to do is use it. It also has some pre-baked in graphical stub connections here. So this is a threaded pipe connection on this, and it's got some graphics to represent that. This nested object here, this family, this pipe threaded family, has a bunch of its parameters already all pre-hooked up for diameters and descriptions and materials and things like that. Also baked into here, I think if I tab deep enough into this, right there, I believe, yep, there's an articulated Cartesian arm baked into this project as well. And every single one of these connectors is hosted to that. I want to take a tangent for a minute here to talk about what that means, that articulated Cartesian arm, because this is critical to how the MEP content works within the productivity pack. That Cartesian arm is some of the incredible power that's going to give us all the flexibility to take this massive unit with a bunch of stuff on it and configure it exactly to what we need. All right. So to know about this, there's two places you're going to want to go in the user guide to understand more about that Cartesian arm and a bit about how it's used within the context of a piece of mechanical equipment. So I believe, let me just look here on my desktop because I've got a whole slew of papers here. Yep, it's chapter 6. That's exactly what I'm looking for, is chapter 6. In fact, let me pull this forward here. This is the user guide that came along with the pack. In my case, it's saved directly on my C drive, so I have quick and easy access to this. And if I scroll down here into chapter 6, yep, there it is, the articulated Cartesian arm. This is the one that ships specifically with the 20.1.1 version of the MEP Productivity Pack. This is the one printed October 10th, 2022. So you all, if you have a current version of the pack, you should be able to kind of review this exact same thing. There's similar documentation in previous version years, but this is the latest one that's released, and so I want to talk about this at the moment. All right, so the articulated Cartesian arm chapter here, it talks about all of the parameters that relate to it. So there's, if I scroll down just a touch, where did it go? Did I scroll too far? I must have. Let's get back up here. Articulated Cartesian arm, chapter 6, that is page number 86. It didn't drink me right to the spot. Okay, here we go. There it is. Articulated Cartesian arm. This explains that piece of equipment. It gives sort of an exploded view about it, and it talks connector by connector or articulated arm by arm exactly what the kind of configuration is and what each of the parameters and properties about it actually mean, whether it's activated or not, what its orientation is, what its tilt, roll, and rotation properties happen to be, its position. It talks about the positioning control numbers out there, so you understand a bit about like where within the face it's actually controlled and all the different types of powers it is you have for this arm. And every single connector that's in there and every single sort of graphic protrusion, either the pipe or duct or whatever protrusion, they're all associated to these arms, so they can move anywhere within the families. And that means you can build literally any piece of content, 100%. Talks about the parameter sets specifically for different kinds of components and what each property is that it means. So if I'm looking here at the supply components, like the duct height and width that controls some of the graphic properties about it, as well as the physical dimensions of the connector. It also, what the angle actually is going to be. This controls sort of the linked face angle, what the origin control position is going to be, the outlet X, Y, and Z properties, and in some cases, there's other ones that show up depending on some of the options that are hooked up here, but those are the ones that are the most important. And it explains kind of how they work, how this all functions within the family. And we're going to use these specifically to actually build the piece of equipment that we're going to be talking about today. All right. There's also a really good tutorial on this, on how this works for plumbing fixtures, how this works for mechanical equipment, so you can see some other examples. We're going to be going through our own example today and putting together this piece of equipment. Okay. Now, along with this, there's another chapter that I recommend that you familiarize yourself with, and that is the chapter 13 in this current guide, which is specifically the mechanical equipment chapter. And it talks about how the equipment itself can auto size and some of the other aspects of this, some of the face-based properties and performance table families, and how all of this can work together alongside those arms to really give you a lot of power. Now, we're not going to use quite as much of some of this functionality today. We're building a one-off piece of equipment that we're going to control as fully as we can. So I'm going to walk through step by step those processes in putting this together and show you some examples of how you can figure out how these different parts and pieces work. Is this something that I'm going to do every single time I need a piece of equipment? Absolutely not. I'm going to try and pick something close and use it, but when I need the exact piece of equipment or when something just doesn't exist, I might go through this so I can have the ability to place the connectors and information that I want. So now let's take a look at today's piece of content, the Trane computer room air conditioning unit that we're going to take a look at today. Give a quick introduction to this. So within this product line, what I've discovered so far is that there's 4 primary computer room air conditioning or computer room air handling units. So there's actually, I think, about 8 different major configurations of this. Each of these major pieces of equipment have multiple sub options for different features that can be added on optionally, and a whole range of different sizes for these pieces of equipment depending on what your demands are, right? We're not going to have time in this series to go through all of it because we've only got a 2-part series here. So we got to get through as much as we possibly can and get you an understanding on how you can build this unit up. And if you wanted more about this particular unit, you would just simply add, include more features and maybe not delete as much as what I'm deleting, or maybe save as a couple of extra families as you start building this out, and then start to isolate, a family for upflow or downflow, a family for the roof mounted separate from, the perimeter style. Like there's all kinds of different items you could be building from this. The concepts is what we're focusing on throughout this series to get to an endpoint that is meaningful, that is usable for you and your projects. So what am I actually focusing on? I reached out to Trane and I asked for some very specific cut sheets since I couldn't find them on the website directly. And what I got was a CyberAir DX Perimeter Precision Air Conditioner. This is a particular model, one configuration meant to be on the perimeter of a computer room for cooling in a large area. And we're going to be focusing on building this. Now, specifically within this, we are going to be building the upflow configuration. We could also build the downflow. It's just an additional set of options, probably an additional type catalog. I'd probably save it as a new family just to keep my end user's navigation of this as easy as possible. So I'm going to build one of these variants, which is the upflow. And I'm going to be focusing in today's session on the 88 kilowatt version of this, and we'll build out the other types and sizes in part 2, just so you have an idea of where we're focusing here. And I'm also going to be focusing very specifically on the air-based heat rejection as opposed to the chilled water heat rejection, or there's a bunch of other options that exist inside of here as well. So in order to keep this condensed to a specific known item, this is primarily what we're focusing on. I'm also not focusing on any secondary cooling options. So again, separate cooling tower type connections. I'm not focusing on that, though we could absolutely include them. It's just more parameters and more connectors to focus on. I'm pretty much sticking to the standard options wherever I can. So if you happen to have a cut sheet for this and you want to kind of follow along with the numbers that I'm entering, I am going to be specifically building out the CFU, 088 D2A unit from Trane. Okay, that's the specific perimeter precision air conditioning unit that I'm going to be working on. That's the model number. And again, as we go through this series further in, we're going to be adding more and more types. So a lot of that 088 will include other sizes. We'll have a 105. We'll have 070. We'll have a number of other values inside of here, and we may even have enough time in our next session, part 2, to include a downflow in addition to the upflow. So the CFD as opposed to the CFU. We'll find out. It depends on how far we get. So actually, let me back up one step here, just so that we're all sort of on the same page. When I was going through the Trane product line here, this is effectively the unit that we're going to be going through and putting together. This is that particular perimeter graphic, but there's a number of other style of graphics. This is also a CRAC unit. This is also an in-server row CRAC unit. They're similarly sort of spec'd out, but they have different features and functions. And so the one that I'm focusing on here is this guy, computer room air conditioning direct expansion. It has a different name in my cut sheet than what's up on the website right now because my documentation might be a little bit older. In fact, this is specifically the document that Trane sent to me when I asked for some of this information, and this is everything that I'll be using as I'm going through. So it's this unit. Once again, if I go down to the data here, where was it? What page was I on? It was page 33. That's where I'm at. So I'm focusing primarily on this unit right here. And up higher in this document is all of the individual spec sheets. Way up on page 14, there's all the individual properties and parameters. So we're going to be building this specifically in today's session. So part 1 is I need to take a look at that piece of equipment, that standard piece of equipment, and get it pared down to only what I need for this. This is all I need. I want to get the general form to look sort of like this. I want to get the connectors in approximately the correct positions so that I can begin to actually put in some of the data values for this family. So let's go through and focus on how we can remove the unneeded connectors from this family. We only need specific ones. We want air supply, air return. We want the 2 DX connectors. Maybe I want to keep the chilled water supply and return lines if I wanted to have that secondary feature. But pretty much everything else is self-contained in this unit, and I don't need, I do want to keep the condensate, but everything else I pretty much want to get rid of. So I don't need outdoor air. I don't need makeup air or exhaust air. There's a lot of the stuff that I don't need there, and I don't need, hot water coils or steam coils or anything like that, because again, that's all self-contained from what I'm understanding from the documentation. So once we get into the actual family, we're going to take a look at 2 different ways of removing these connectors and the values that we don't need. We're going to start with the manual technique, and that is effectively going through the family types dialog, looking for parameters we don't want, and then simply deleting them. That's one way. And then visually deleting the connectors themselves as well. The other way is a very automated or much more automated technique, and that is by using the tool Family Processor. And just a week or so ago, I did a webinar, and it's now up on our YouTube channel, introducing the Family Processor workflow and showing kind of how that can work to really automate a lot of family edits. In today's session, I'm going to be using that information specifically to delete a lot of parameters that I do not need. It's going to help me in a big way go through and just rapidly clean up a lot of this family, which is going to make it far more performant for the rest of our processes today. So let's do that. First off, I'm in the family. Before I start making any edits to this family, I should probably save it someplace so I can continually save and have record of what I'm doing. So I'm going to do a save as, file, save as, a family. And this, I'm going to be dropping into my C drive. I have a temp folder sitting here, and as before, we've got a custom content creation series, and I'll be saving the family in this location. Now, since this is a very particular product, I'm going to go ahead and give it a name so that I know what this thing is for future reference. Where did my cover sheet go? I am expecting to have, there it is. I needed to make sure I had the product name in front of me. So I'm going to go ahead and just type this out. This is the Cyber Air DX perimeter. I'm going to abbreviate precision air conditioner. And this is from Trane, and I'll probably update that name later just so that it's a bit more clear. But for right now, I want to make sure I'm very clear as to which component it is I'm working on here. There's no space there, right? I didn't want a space. Yeah, cyber air, it's all one word on their documentation. I probably should include some things like the 21 to 105 kilowatt, but I'll ignore that for now. I'll put that in the type data. This right now is specifically that particular family. I'm also going to go here into options. Every single time you edit a family out of a project, it defaults to 3 backups, and I don't like that. So I'm going to make it 1 backup, and I'm going to have my source view set to my default 3D view sitting here. I might update that a little later on. Go ahead and save this. So within this particular view, there's a lot of things that I can get rid of. This component right here is the outdoor air intake. I don't need that. This component here is the exhaust air discharge. I don't need that. I really only need for the air connectors the supply and the return, those 2 devices right here. There's a ton of connectors here on the side face of this unit. Looks like there's nothing on the back or the left edge over here. So the right and front face of this have all the connectors potential. I can see them all from this one view orientation right here. Oh, that's zooming into that object that I have selected. Let's deselect that and try this again. So there's quite a few of these items that I want to get rid of. Again, these ones I want to keep, these DX configurations, because I want to have that able to go to a separate condenser unit sitting outside the building. This component over here, water source, heat pump objects, I don't need any of this water source heat pump stuff, so I want to get rid of that. Burner inlet, I don't need this either. I think, yeah, that's a gas component here, so there's a lot of this stuff that I want to just delete, right? Condenser piping, don't need that. In this case, what is this one here? That was the, yeah, condenser water flow rate, don't need that. Chilled water over here was one that maybe I needed, so I might want that. Yeah, chilled water component values. The condensate drain I want to keep, the electrical I want to keep, but pretty much most everything else I want to get rid of. So I'm going to delete all that stuff. Now to do this manually, I would delete the fittings first out here, but I would also then go through the family types dialog, and I would begin to delete anything out of here that I really don't need for the purpose of this particular family. There's a lot of these yes, no checkboxes I could probably get rid of here. As I scroll down, there's quite a few properties in the mechanical segments and fittings. This exhaust area I could get rid of. The flue vent I could get rid of. The inlet intake duct stuff I could get rid of. Outdoor air I could take and get rid of. I just want to keep the return and supply stuff primarily. That's the majority of what I want. So there's easily 2/3 of these segments and fittings up here that I can pretty well get rid of straight away. In the plumbing area, there's domestic piping down here in case this has some domestic in and out flow. There's a lot of stuff here I could probably get rid of on the plumbing side. In fact, pretty much everything except for the condensate. Mechanical side here, there's a lot of things here, the condenser and gas burner, gas heat. There's a lot of stuff here I could get rid of. Now, normally to get rid of these items, you would select a particular parameter and you would hit delete one by one, select, delete, select, delete, select, delete. And I can do that. It's going to take a minute, but I can do that one by one if I really wanted to. Now, for me, I find a faster way to get rid of this is to use something that lets me batch delete some items. And that's where we're going to dig into the more automatic technique. I'm going to be deleting a lot of these elements out here, a lot of these items inside of here that I don't need, simply by filtering for these parameters and deleting them, adding them to a deleted list in Family Processor, and just let that rip. And it'll take way less time to get rid of them. There's also highly likely some extra properties down in other, buried down here, that and or in identity data, no, just down here in other, that I may or may not need as well. And so I can get rid of some of these values potentially if they're just control values. So I might get rid of some of that too. We're going to find out though when I get into Family Processor. So first off, I'm going to delete the dependency here on the components. I'm going to delete quite a few items here. Just deleting this guy because I want to get rid of it. don't want it, don't need it. Don't need any of these items over here. I'll do a window selection in this case, in this scenario. Let's see here, across the top, there's a few of these connectors I don't need up here. A bunch of stuff on the side to the right over here that I don't need. I want to keep that one, so I'll get rid of these ones. Control select, get rid of this guy as well. Delete all that. So that's all gone. So I'm pretty well cleaning up my family in a fairly big way here. Now what I'm left with is my condensate. I'm left with my chilled water in and out, and I'm left with the DX connectors, supply and return air. So visually, this is a bit better. It's a little less muddy. Oh, and my electrical connector, of course, I want to keep that as well. Now, the time has come for me to go through and delete all the rest of those values out of the family. So up here on the CTC management tab, I'm going to be using family processor because I find this to be the most efficient way to rip through and clean up a lot of these things. And now I'm going to be explaining a bit more about those connectors and their positions here in just a moment. I did see a question roll through about how you edit this and how sometimes it feels like you have to edit a lot of things to get one outcome. And well, that's sort of true. You also have to go through and model a bunch of items if you wanted to create something, and then remodel a bunch of items if you wanted to create a slight variant of it. So there's a lot of advantages to using this once you understand it, as opposed to manual creation over and over again. So I'm going to start with brand new settings here. I'm only focusing on the active model, so I don't really care about any of these sort of family level processing items here, unless I had sort of a units of measure file that I wanted to template. I will be making a manual modification to my length values here in a moment, but for now, we're just going to jump over to change parameters. This is where I want to focus on stuff. Now, I don't actually need a shared parameter file because I'm not adding any new shared parameters, but Family Processor wants one, or else it won't let me actually go through and process stuff. So I'm going to go ahead and just use a shared parameter file here real quick. That will allow me to have a list of all of the parameters if I was to ever do an add shared parameters here, which again, I'm not going to do today. I'm only focusing on the delete parameters list. That is what I'm really interested in here. Okay, so within the family now, if I wanted to remove a bunch of these, let's just say I'm looking to delete all of those gas parameters. Type in gas, give this a minute to refresh, and once it refreshes, it's going to list out for me any parameter that is in my family that relates to gas. So there's gas burner, there's gas heat choice, there's all kinds of gas stuff. Refrigerant gas now I want to keep. This one I think I actually do want to be keeping, but has gas supply, I don't want any of that. So I'm basically going to be selecting everything and then intentionally deselecting the ones that I want to keep. So yeah, gas supply, pipe size, inlets, gas heat, all these properties, none of this is actually needed. It's all garbage for what I'm doing. So I really just care about the refrigerant gas. Let's add those to the list below. There was exhaust, EXHA, I'm going to put in here and just kind of see what shows up for exhaust parameters. This is live filtering this list as I'm typing, so I'm only going to type as much as I absolutely need, just to make sure that this comes up with just as much as I absolutely actually have to have in this list. So exhaust air, exhaust duct, exhaust fan, all of this stuff, exhaust filter, yep, don't need that, exhaust outlet, all garbage. Heating exhaust, I believe. Oh, actually, I'll keep that data for now. Nope, I don't need that either. Return exhaust inlet, I might keep that. Unit has exhaust fan. No, it does not. So I'm going to go ahead and get rid of that value as well. So you can see this is letting me rip through and pull out just a ton of properties really quickly here. There might be some that I onesie-twosie want to come back and fix later on. I'm just going to do one more here real quick. Makeup. I think I got that. MAK. Yeah, MAK. No, I put MAKU. Whoops. Let's go back here. MAK. Just do my makeup air real quick, and then I'm going to jump into the actual family and start doing work, because you get the idea. I don't have to go through and delete every one of these. I'm just going to do it for just these few. Do I not have makeup air? What was that other one that I deleted? I forgot now. It was I forget. Well, that's fine. We'll just do these values here and we'll clean up a lot of this. Actually, let's do hot, maybe. Maybe it's just hot water. I might want to look for domestic. Domestic might be some good ones to get rid of. Just to, again, clean out. Yeah, domestic hot. This is great. Domestic hot, the hot water, I don't need any of that. Unit has hot water, get rid of all of this. Add those, and then one final one, domestic. Just real quick, we're going to get that one, and then we'll process this and be done. Again, my goal here is I need to get to the actual editing of the family. So we're gonna stop here. Now, I did see a question come through. When you are deleting so many of these parameters in a family of this size, how do I make sure that all of the built-in equations that are required for this thing to function are actually going to still function? Because when I delete the parameter, there might be other stuff that could potentially be deleted that might be really important. You're absolutely right. That is a potential fear. The good thing is that with our content, with all of this MEP Productivity Pack content, if I'm deleting a whole entire family of parameters, I'm just using that term generically, family, but if it's all domestic stuff, there isn't anything outside of that that's dependent on it. If I know I don't need the domestic properties, I can delete the domestic properties and I'm golden. It's good. If I don't need the hot water return stuff, I can delete that and it's isolated to itself. There isn't a lot of dependency outside of that within this particular family, within this specific family, that is what was the HVAC configurator. It's very isolated. Now, with the electrical side, there are a lot of electrical dependencies. That's true. And so when I'm dealing with electrical, I tend to leave those and I tend to focus on them one at a time. But I'm talking about all this mechanical piping stuff that's just there. They're grouped in nice little family collections here that I can very quickly and very easily strip out to make my family more easily navigated. But yeah, the electrical side, I tend to actually focus on those one at a time. You'll notice I didn't put any electrical properties in this list. I left them alone. Okay, let's select families and begin. I'm doing this on my current family. Let's begin the processing. You can see a whole long list of parameters here that are all expected to get deleted. And I'm going to hit continue, and it's going to rip through and pull this stuff out. It's not everything. There's actually quite a few areas that I didn't delete, and I probably should have for the best possible efficiency here. But this is going to get us well on our way to being able to use this family as efficiently as we possibly can. There's probably some steam properties in here that I could have kept or that I could have deleted because I don't have external steam on this. There's probably some evaporator stuff that I could have probably gotten rid of as well, but this will get me ballparked. It'll get us into a slightly more navigable UI within the actual family types editor that I need. Now, family processor is actually done. I believe it's done, and it jumped to the background there, and I got to find a way to pull it to the foreground. There it goes. It just pulled up my success. It was 154 successful parameters deleted. That's glorious. That saved me a bunch of manual deletes, and there's one bit of info saying, I processed your family. That's it. That's all I care to know about. I can close this down. I'm going to commit the changes to my open family document, and now when I jump to the family types dialog, it's not short, but it's way shorter than it was before, and these areas inside of here are going to be a lot easier for me to go through. It looks like outdoor was what I was looking for, outdoor intake, not makeup. I should have deleted all those as well, but that's okay. There's still quite a few of these values that got pulled out. The domestic area is all pulled out, and I'm back to needing more or less what I need here. So let's jump into the next major step here. Let's establish general properties and locations of the major connectors. And we're going to get through this in the final little bit of today's webinar in this session, part one. We're going to get sort of the look and feel of that perimeter precision air conditioner by Trane, that CRAC unit that we're going to be able to then further develop in our next session. So what are we going to focus on here? First off, the one thing that I like to figure out is the unit size. I like to get this 100% locked in for at least the model that I'm working on so that I can get everything else positioned in relation to it. And then I like to focus on the two major air connectors, the return connector up top, that's the first one that I'll focus on, and then I'm going to focus on the supply connector, which is actually going to move from currently up on the top down to the front face of the unit. And I am specifically going to be using the front, left, right, back, top, bottom orientation as specified in Revit, which means when I'm specifying the unit size, I may actually be using some what you might consider odd values, but I'm going to do it on purpose because I want the unit to size correctly. I could always rehook things up if I really wanted to use the right named parameters, but for me to be able to get the proper size unit, I know in my head that all these units work pretty much the same way, so they're predictable. I'm going to leave this the way that it is. Then I'm going to locate the electrical connector and then the DX in and out. And that's going to be effectively it. That's what we're going to focus on today since I've gotten rid of most everything else. I think I did keep the chilled water in and out, and I may actually locate those after this session just so that I can have them sort of relatively positioned where we want them and sized how we want them. So let's jump into Revit and actually focus on modifying this unit accordingly. So in this unit, I'm going to make this dialog just a bit narrower here so we can see the unit in the background. In fact, let me okay this and let me pull this to the side so we can actually see both simultaneously. Normally when I'm doing this, I'm using two different monitors, and it makes it real easy because I can have my family types dialog on one screen and the full view of the unit on the other screen. But because we're only able to present from one, it makes it a little easier to share this here. We're going to be kind of showing this off this way here. All right, so in this environment, the first focus is the unit size. And I've got the cut sheet sitting just to my left. You can't see it, even though I held them up in front of the camera because the camera's not on. So we're looking here at the height, the width, and the depth as spec'd on Trane's documentation. The height is 88.1 inches. In fact, I could probably jump over to here because this way you can see these, and I'm on page 14 at the moment. So let's get up there. Page 14, we are focusing on this unit right here, which is the CFU 088D2A. So the unit dimensions are sitting right down here. This is the unit dimensions overall. If I had the hot gas reheat, which I don't, I would have a slightly taller unit. So I'm focusing on these numbers right here. And as you can see, the unit dimensions are specified height in inches, width in inches, depth in inches. That's how this manufacturer specs and documents this. So even if you are metric, you'd want to still use inches in this case because that's what you can order it as. You want those sizes accurate. So because everything inside of here is spec'd in inches everywhere, it's all inches. The filters are inches, everything is inches. I'm going to make one quick modification to my family, and that is I want all of my length values to be spec'd in inches because it's going to save me from accidentally typing in 88.1, forgetting to put the inch mark, and ending up with a unit that's 88.1 feet. I do that all the time. You probably do as well. I don't know, maybe it's just me, but I'm going to modify my units of measure in my project to just simply be inches and save myself all kinds of headache, and also help me visually validate this in the future. So if you go to manage project units, you can just simply take your length values here and modify it from feet and fractional inches to something like fractional inches. I wish, oh, they do have decimal inches. Look at that. So I could put decimal inches in here as well. That would be just fine. Rounding to, we'll just do, I don't know, 2 decimal places. That'll be good. I don't think I have anything beyond 2 decimal places. And I can always suppress the trailing zeros if I need to. And that way I can get what I need. Now, the cool thing about this is that when I load this into a project, the project's units are going to take over anyway. This is just for me and my convenience while I'm editing a family. Since all of my manufacturer documentation is inches, I may as well just save myself the headache and match the units of what they've given me. So now when I jump over here back into the family types, and this is great because now open up, thank you, there we go. As I'm looking through the dimensions here, anything that's length based, that's not say duct or pipe size based, where was it at? I think it's in dimensions down here. I probably should collapse all those electrical properties just to save myself headache. Dimensions, there it is. Product depth, product height, length, width, these values here, I can modify these, the ones that are relevant, and it's going to match up with the manufacturer documentation. So the easiest one here 88.1. Just type that in. That will be the height of the unit, and that's going to be fantastic. Now, if I recall correctly, the length of the unit actually runs this direction, left, right, on the unit. So I'm going to pretend that is the length. I might be wrong. No, actually, I'm dead wrong on that. The length runs this way, front to back on the unit. That's the length. But the way that I want to lay this out is I want this to be the longest dimension so that the front of the unit faces front. If I pull this down here, you'll notice that's the front orientation. So what I'm going to do very intentionally is I'm going to actually cheat, and I'm going to use the width of it. Looking at the front of the unit, that's going to be considered the width of it. I'm going to put in the manufacturer's width dimension, which actually is the width, which is great. And that's, what is it, 118.4. And then finally, for the front back dimension here, I could potentially use the depth. I don't think that's hooked up in the family right now. So for right now, I'm going to use the product length for this value, and later on, I'll go back and actually hook up that depth right there to the family correctly. We'll do that probably in the next session. But for now, I'm just going to use the length property here as the unit's depth, and that is 40.3. So just to make sure that I've got about the right proportions on this family, I'm going to go ahead and hit apply, and we're going to see this unit morph and change its shape to match up pretty much with sort of the configuration that the manufacturer has as far as the overall body of the unit, and a little bit on the stand that's optional below it. Yeah, that's perfect. So I'm going to hit OK here, and you'll notice one of the really cool things about this family is that all of the connectors, well, they stayed associated to their proper face. They're already constrained because of how this family works. These all stay constrained to their proper face, even when I flex the unit. So if you were building this 100% by hand, you'd have to actually make sure that you built all those constraints in. That's a lot of reference planes. That's a lot of extruding. It's a lot of components when all I really needed to do is just change the physical size of this unit, and it already has it. Now, if you wanted to take this supply air diffuser, or supply air connector rather, and move it to the front face, well, you'd be remodeling a family. In my case, I can actually simply take this thing and orient it to this face fairly easily. In fact, let's do that real quick. I know next I'm going to be working with the return diffuser, or not diffuser, I keep saying diffuser, return connector, but I want to get this supply connector out of my way. So I'm going to go into the family types, and we're going to take a look at the orientation of that supply air connector here. So I probably could just collapse a bunch of these just to make myself not have to scroll quite so much. And I think it remembers that from session to session. We'll find out here in a minute. Since I'm done with the dimensions, I'm going to collapse that. We're now in the mechanical area here. And in the mechanical area, I want to work with that. Nope, that's not right. I want the mechanical. Where is it? I forget now. Can you scroll for me? Loads, alignment. Where is that property? Chilled water. I forget. It's in here someplace. I didn't delete enough items, obviously. I still have Steam. I still have a bunch of these items that I don't need. Mechanical, model properties. Good Lord. There's always a lot of stuff. I don't think I deleted supply airflow. At least I sure hope I didn't. I didn't mean to, if I did. Supply airflow, supply fan, mechanical loads. I know it's not mechanical loads. Did I accidentally delete supply air? That would not be ideal. I'd have to take a whole step back. Segments and fittings. There we go. Segments and fittings. I collapsed it right in front of myself. That's fantastic. Segments and fittings. There it goes. So here we go. In this area, the supply air, I was focusing on taking this supply air connector and putting it on the front face. Now, if we go take a look at the documentation, that is the Cartesian arm documentation, it tells us that what we really need is this this supply outlet angle. And we don't even have to go to the documentation necessarily, because if you mouse over these parameters here in the 20.1.1 version, it tells you, look, supply outlet angle, it tells me if I want it on the front face of the unit, the literal front face, I have to just put in a value of 270. 270 equals unit front face. It tells me right there. So I'm just going to say, all right, that's cool, 270, and hit apply. And that's going to get this connector, the supply air connector, out of my way, and that's going to let me focus on the return air connector specifically. Give this thing a minute. It's going to reorient itself, put itself, in this case, down there at the bottom edge of the face because it's got all of its control locations, and we'll move that in a minute to actually be sitting over here on this edge of the unit. But now that we've got that out of the way, let's pull this over just a little bit. We want to control the physical position size of this return air connector, which basically takes up 3/4 of the top of the unit. Now, here's the deal. I looked through the documentation. I looked hard. It doesn't appear that there's any documentation about what that dimension actually is. I couldn't find out for that air connector if it's a specific dimension or not. So what I'm going to do for now, and what you would probably want to do as well, is looking at the unit that we're building, get down to the one that I'm actually putting together right here. This guy is the one that I'm building, the 088 to 105. This is approximately 3/4 of the top of the unit, just shy of 3/4 of the top of the unit. I'm going to inset it about 2 inches from each of those 3/4 width dimensions. And so since this is going to be very consistent on this unit, I'm going to go ahead and start with just a formula here just to get this thing positioned to the right dimension consistently. And then front to back, I'm going to take 1 inch off the front, 1 inch off the back, and just make it inset 1 inch from the edge of the unit. Again, there's no dimensions out here that indicate this specific thing and what its physical properties are. So I'm going to estimate that for myself. So if I needed to, I could always go to the manufacturer and ask for something really specific connector, documentation here, if they'll give it to me. And if they don't, I don't really need it because this isn't critical for the functionality of the unit. I'm not really going to be connecting legitimate ductwork to this. I'm just going to be using this as a host for an air terminal eventually so that I can get the airflow to register to my space as the supply air and then have this register to a return grill so that on this face unit so that I can actually return in. So the physical dimensions for this aren't absolutely 100% critical. Similarly, I don't have actual dimensions for the locations of these pipes either. I have a general idea of where they are, but Trane doesn't provide me a physical location, so I can't really know. What I do get is the sizes of those connectors. So I'll put that in. That's the best I can do. So let's go through the exercise of modifying this connector accordingly. So in this case, I know that this is the width of it and this is the height of it. I believe that's what I have. Let me just verify. I'm going to zoom in real quick. That's reversed. Width is this way, height is front to back. So I'm going to be using the height property of that return connector, the width of that return connector, and I'm going to use the dimensions of the unit to actually drive those. So if the unit changes physical shape, it's going to change the shape of this as well. I'm going to build my own relationship so that it can be pretty darn close. So in this unit here, if I go back to, let's collapse a few more of these guys so that I have some values side by side. Just collapse this. I have a slightly smaller scroll bar here. The dimensions that I care about are the length of the unit, which is actually front to back depth in my case, and the width of the unit, which is the overall width. So I'm going to be using those properties here real quick in my return connector formula. Product width, I'm going to copy this, go up to my return connector here, which is my return width. I'm going to use the same property for that. Return duct width currently says 24. I'm going to pull some tricky maths here and just take this number divided by 4. I'm going to surround that in some parenthesis here. I'm going to take that number, I'm going to multiply it by 3. And I could have just probably done times 0.75. That would have also worked instead of doing it the way that I did here, but I'm just going to do it so I can keep my brain straight. And then from that, I'm going to subtract 2 inches from that number, whatever that happens to be. So 2 inches. And when I do that, when I actually click away, this should get me pretty darn close to 3/4 of the width minus a total of 2 inches, which is 1 inch each side. So that in this case is 86. My overall width was 118. That'll be close enough. My product height, or my connector height right here, I'm going to do something similar for that just to kind of have the position there, we'll use the length of the unit and just subtract 2 inches from that. So it'll be exactly 1 inch off the sides. So copy this, return, where is it at here? Return height, there it is. So that number minus 2 inches. And so as I do that, that'll get me the approximate dimensions of this. It'll be close enough for my purposes. It'll get me just what I need there in that case. I'll probably eventually take this and round this to the nearest whole inch, but I have the physical dimension that I need. Now what I need to figure out is how to position this correctly on this top face. And for that, I need 2 properties. I need to know what the origin is of this, and I need to know what the datum is of this. The datum kind of controls the position of this overall arm relative to its origin point. Like, where am I holding on that origin point to control its position? And then on the inlet origin right here, this is kind of where on the face am I dimensioning from. So am I dimensioning from this corner, this face, the center of the face? Where am I dimensioning from? And then from that, I can configure out over here what my actual X, Y, and Z positions are going to be. So for right now, if I look at this, my datum here, what I want to do is I want to control it really from the lower left corner of this. Now to figure this out, this datum, I read it in the documentation. I wasn't quite clear, so I went and talked to the team that was building this component, and I asked them, I said, so how can I best explain this? And they said, stand at the origin of your family, stand down here, and look at the face that you're trying to control. Look at the edge that you're trying to work with. And when in the documentation it talks about quadrant 1, 2, 3, 4, it's going kind of counterclockwise. When I'm looking up at that face, it's kind of like looking at a reflected ceiling plan. Everything's kind of reversed in my brain here. But what I figured out for this is that I can do one of 2 things. Since I know I'm controlling it from a corner, I can either start with 1 or 2 or 3 or 4 to know which quadrant I'm in, or I can take a best guess here. I'm going to guess that it's quadrant number, let's just say 1. I know this is wrong, but let's try it. Quadrant 1. And as I apply this value, and I also want to make sure that I'm holding the front left edge of this unit so I know where I'm relatively positioned based on. So I want front left, that is number 3. So I want to use position number 3. If I just mouse over this, it tells me all the different control points that I could be holding to change what my X, Y, Z's 0 location is. In my case, it's going to be based on the front left corner. And so that's right here, front left. So I'm going to hit apply right here and just see what happens with this particular connector. It should move, and it's going to be positioned 4 inches off in the some direction, which actually won't matter because it's the Y direction, so it's irrelevant. So actually it is not irrelevant. It's positioned 4 inches off in Y direction right here. So it's holding the wrong corner. My guess of datum 1 was wrong. So I'm just going to come back here and take a look and say, well, the other one that I want is quadrant 2. I'm pretty sure that's the one that I want. Hit apply. And actually, I knew it was quadrant 2 right from the start, so I could have just started with that, but I wanted to show that if you get it wrong and you hit apply and you get at least your anchor point correct, it'll position it in a way that you can go, okay, I put in the wrong dimension or the wrong quadrant, and now I've got it in the right position. But this moves it in any face to any position. And this is really powerful because now all I have to do for that return connector is say, well, in the Y position, it's 4 inches, which is actually wrong. I want it 1 inch. In the X direction, left, right, I want it also a 1 inch offset. I'm just going to tell it 1 and 1. And then that'll position that return air component in exactly the right spot. Let's just hit apply here. That's going to move. It's going to shift. I probably want its protrusion or its depth to be something a little bit smaller as well. But in this case, it's got itself positioned exactly where I want that return connector on the top of this unit, right? Similarly here, the supply outlet, same exact game. I want to position it here off the bottom left corner. When I'm looking at that, I'm pretty sure that I want this to be in quadrant 2 for the datum. The bottom left corner of it is what I want to hold. The looking from the inside of the unit out, that is. For the actual position, the orienting position, since I'm on an overall face, I basically want to do, again, the front left edge down here is what I want to control. The elevational is always at 0 when I'm on a front face. So we're just going to stick with this here. So if I mouse over this, give this thing a second to refresh. Here we go. Front left, once again, that's a 3. And so I'm going to hit apply. My offset is currently 3 inches up from the ground at this point. So it's going to be over there on the edge, or should be over here on the edge with the connector on the face. Yeah, perfect. Right there, exactly where I want it. My position here is going to be 1 inch off that bottom left corner on the Z direction, vertically off that corner, and then 1 on the X direction as well. The Y doesn't make any difference because it's sitting out here on the face. There's no offset. So I could just, for visual purposes, so I don't confuse myself in the future, I could set the Y to a 0 because it's not doing anything anyway at this point. Hit apply, that connector goes to the right spot. And then all I have to worry about is the height and the width of this. Just going to modify these numbers. So really, when you're dealing with the connector, there's a few things you care about. You care about where you're holding on the connector, what control point you're dimensioning to. You care where you're dimensioning from on the face. You care, of course, about the dimensions of it. And then you care about its position. You're either going to control the X and Z, or X and Y, or Y and Z. It's one of those. It's any of those individual connectors here. Now, if you needed to, you could also rotate on the face. I could change where's the control for that? Actually, the rotation is locked. So if it's a supply duct, it's just locked down. I could rotate it if I wanted to by simply getting rid of this formula, and then I could rotate it at 45 degrees or 90 degrees or you name it. I could rotate this wherever I needed on that particular face if it was required. The dimensions of it, though, let's get that dimension set up. Once again, I'm going to be using the width of the overall unit. This, according to the cut sheets, looks like it spans 2 of the units, so it's about half the width out here. There's probably actually more, maybe it's 1/3. Maybe I just exactly match the dimensions of the return air properties up here. I could absolutely do that just to save myself some time in inputting properties. So if I wanted to grab the return duct width, I could grab that, copy, and make that, in my case, I think that's actually going to match the supply duct height. No, it's going to match the width. That is correct. Match the width. And then return duct height, we'll grab that property and we'll match that. And then if we correct this in the future and make it an explicit inch dimension rounded down to the nearest whole inch, then that will save us those oddball fractional numbers there. So copy this, paste that into supply duct height right here, and apply that. Once we apply this, the supply duct will be held an inch off the edges and then size itself similarly to the return sizing in this case, so that we have a good starting point. All right, so it looks like we're pretty much running out of time here. There are other properties that I could control as well. We've already talked about the positioning of these items. We'll talk about those quickly at the beginning of part 2 and actually position the electrical connector, the DX connector, and the water, chilled water return and supply in part 2. So real quick here, let's just go over the overall outline and talk about where we are. This is a little bit off. We've talked about in this session introducing the master equipment family, outlining the basic unit that we're building. We've removed most of the unnecessary features from the master. I'm going to do more of that off screen using family processor as well. We've established most of the connector locations and talked about some of those base properties. Now we've kind of begun to get this all set up. In the next session, we're going to talk in detail about refining the connector values even more, specifically from cut sheets. We're going to establish most of the desired types and values that we want, and then we're going to test this family out. So for this, I'm going to go ahead and say thank you. We always appreciate when you participate with us live in these webinars. We hope you find this valuable, and we look forward to seeing you in part 2 of this series.